For a balanced and positive system, what's my A line voltage? Give it to me in the chat. Give me the proper two subscripts. V what? For a balanced and positive system, it's going to be VAB, right? Next is what? VBC. And last, VCA, right? These are the line voltages for a balanced and positive system. Do any of these magnitudes or subscripts stand out as not matching this? Yes, AC, VAC, right? That should stand out. Everything else looks fine, right? VBC is our B line voltage. So in order to get these angles in here right, we need to graph these complex phasors. So we're going to use a reference. What's the reference that we always want to use? What's the biggest advantage to use? We're going to use, oh, didn't like that. We're going to use our A phase voltage at 0 degrees, right? Great. If that's our A phase voltage, how would I normally find VCA? First, VA neutral, I can find the VAB, right? That's our A line voltage. How do I go from A line to C line? What do I got to do? I'm going to go this way by how much? 120 degrees. Great. First of all, if this is at 0 degrees, what's my A line voltage? That's going to be at 30 degrees, right? So 30 plus 120 is what? 150, right? Great. So we've got VCA at 150 degrees. Now, here's VCA. How do I go from VCA to VAC? Well, notice the positive and negative polarity are just opposites. Remember, we talked about the subscript that comes first is the positive and the second is the negative. So notice these are just backwards in polarity. Remember we talked about the very beginning of class? How do we swap the polarity of a phasor? Change the direction, multiply by -1, or lead or lag by how much? Yeah, 180 degrees. Mohammed, DT, fantastic. Thilo, JS, yeah. So if I rotate this by 180 degrees, what's my angle right here? In other words, this is VAC. This is that angle or that phasor we're looking for. So we're at 150. What's 150 minus 180, right? Look, 150 minus 180. I want to go in the clockwise. I want to go in the minus direction. That way my number's under 180. So look, this angle is just minus 30. Everyone with me so far? So VAC is at minus 30 degrees. All right, that one's done. How do we find where IA is? We're taking a lot of liberties, using a lot of easy assumptions. We're going to use, or we're going to operate off the assumption that we're dealing with a lagging circuit, okay? So if A phase is lagging, is my A line current going to be above or below my horizontal? If VAN is 0. Yeah, it's going to be below. And just because it's easier to see the math, we're going to go ahead and put it down in this direction. But anywhere you put it, even if you want to lead it, the numbers still come out the same. It's just easier to do it this way to see it. So if we say IA is lagging, what's my angle right here? Remember, my A phase voltage is at 0 degrees. This is going to be equal to what? Negative theta, right? Remember when VP is at 0 degrees, theta equals negative theta IL. Remember that? That came up a couple times, and it's also from the leading lagging cheat sheet. Okay, so how do we find theta VAC minus theta IA? So let's start with just the magnitudes, right? Really easy so far. We've still got magnitude VAC times magnitude IA times cosine. All right, theta VAC. What's theta VAC? Minus 30, great. Okay, what's next? Minus, so bring down that minus, theta IA. What is theta IA equal to? What is theta IA equal to? Yeah, negative theta. So I'm going to do parentheses minus theta. Does everyone see that? That's the trick. The other one's really easy. This is the only one that's a little tricky the first time you've done it. So if I clean this up, VAC times magnitude IA times cosine minus 30, or negative 30. Negative times a negative is a what? It's a positive, right? Clean it up one more time. VAC times IA times cosine theta minus 30. Does everyone see that? All right, that's the first half. The second half is really easy because there's no, we don't have to rotate any phasors. So next one, VBC. We're going to use that same reference. Remember, we've got to use the same reference. It's the same system. Same reference of VA to neutral is at 0 degrees. And we want to find the B line voltage. Let's go ahead and just find the A line voltage from our A phase. So this is VAB is at plus 30 degrees. How do I go from our A line voltage to our B line voltage? What do I got to do? A line voltage to B line voltage, assuming a positive and balanced sequence system. Yeah, I got to lag by 120 degrees. Great job. Jose, JS, Maria, Thilo. Yeah. So what's 30? What's 30 minus 120 degrees? Negative 90. So VBC is at negative 90. See that? Look. 30 degrees minus 120. Minus 90. All right. There's VBC. Let's show IB. Now, if IA is lagging VAN, then IB is going to lag what? Is it going to lag VAN or is it going to lag VBN, right? So here's VAN. Let's show VBN. If VAN is at 0 degrees, where's VBN, my B phase voltage? It's going to be 0 minus 120 degrees, right? So VBN is going to be down here. VBN, 0 minus 120 is negative 120 degrees. Again, for simplicity's sake, it's much easier to work the math out this way, but it'll work out regardless. If IB is lagging, here's IB. IB lags our B phase voltage, just like IA lags our A phase voltage. Look at this angle. What is this angle right here? Not from 0, but what is this angle from VBN to IB? It's going to be the same negative theta. Does everyone see that? It's the same negative theta. All right. Let's start expanding that formula. We've got, just looking from the top, VBC magnitude times IB magnitude times cosine. What's the angle of VBC? Angle of VBC. It's right here, right? This is theta VBC. We got minus 90 degrees. I've got a minus sign again. Question. What is my overall angle of theta IB? So not just the difference from our B phase voltage to our B line voltage, right? We know the difference between here and here is minus theta, but now we want to know all the way from 0. Look at this. If I start from here, let's use purple, make it, or pink, make it really stand out. Let's start from here. Let's go all the way from here to here. How much is this from here to here? Minus 120. And then we want to go slightly more, is going to be what? Minus theta. So here's a parenthesis sign, right? Minus 120 minus theta. Don't worry. I know this is a lot at first. I really suggest you go through this one more time on your own to understand it. It's going to make phasor diagrams that much easier. All right, let's clean this one up like we did the other one. And then we'll talk about the 2-second step to figure out which one is theta minus and which one is theta plus. And then we'll wrap up from there. So I've got PW2, or the power in watts measured from wattmeter 2, is magnitude. I've got magnitude VBC. There we go. Magnitude VBC times magnitude IB times cosine. All right. What is negative 90, right? No change. What's a negative times a negative is a positive. So I've got positive 120. What's a negative times a negative? I've got positive theta. Okay. Let's carry this down. And let's see what this cosine simplifies to. What is negative 90 plus 120? Negative 90 plus 120. Yeah, it's 30 degrees, right? So now I have 30 plus theta, or we can just rearrange it to match this format of theta plus 30.